This first problem on your note sheet, you can see they want us to simplify what is b to the 1/2 power squared. Well, remember when you have something squared, that means you're multiplying two of them together. So this would be b to the 1/2 times another b to the 1/2. Well, from previous lessons, we know anytime your base number is the same, here it's b, and you're multiplying, we add exponents. So if we add 1/2 plus 1/2, that would equal just b, or b to the first power. So b to the 1/2 squared equals b. And that should make kind of sense, because really what we're doing here is we're taking b to the 1/2 power times 2, or another way of writing 2 would be 2 over 1. So anytime you take something to another power, power to a power, we multiply, and basically what we're doing here is multiplying reciprocals. If we're multiplying reciprocals, it should equal 1. Well, what we ended up finding here is that when we took b to the 1/2 power and squared it, it equals b. They're inverses of each other. Well, what else do we know? If we have something like b squared, what else is the inverse or makes it just b? It is taking the square root. So what this tells us is anytime you take a square root, it's really doing something to the 1/2 power. Square root and power of 1/2 are the same. And that's what we're going to be looking at today with rational exponents. So to kind of sum up what we just talked about with rational exponents, for any real positive number b and for any positive integer n, b to the 1 over n power is the same as the nth root of b. So whatever your exponent is, if it's 1 over some number, it's the same as taking that number to the nth root. Let's look at an example here. On your sheet, you have this example of 8 to the 1/3 power. How would we evaluate that? Well, what we know is that if it's to the 1/3 power, that should be the same as 8, and 1/3, 3 is our bottom number, that means that's the index of the root. So this would be the same as the cubed root of 8. And we can evaluate that, or some of you might know that equals 2. Just to show you it works, let's check it with a calculator. If we go on our calculator here, we've done the cubed root before. The cubed root of 8 does equal 2. Let's check to see if 8 to the 1/3 power also equals 2, which it should. If we do 8 to the exponent, and you want to make sure when you're doing exponents that are fractions that you put them in parentheses, 8 to the 1/3 power also equals 2. So you can see it does work. So anytime you have a fractional power, that's going to be the same as a root. All right, on your sheet, there's just a couple examples we're going to try here. On number 1, they want us to write a to the 1/4 in radical form. All right, radical form, that's kind of what we just did in that last example. We want to write this with a radical, or with a root. So our big number that's going to be in the root is going to be a. What type of root are we doing? Well, we can see 1 over 4, so this would be the 4th root of a. The 4th root of a. Let's try another one here. Number 2, write this one in radical form. So now we want to do the same thing here. X to the 1/5 power, what would that be in radical form? That would be the same as the 5th root of x. All right, let's try some other ones. Number 3 now, they want us to kind of do the opposite. They want us to take a root or radical and write it in exponential form. So kind of the opposite of what we were just doing. All right, well this one is y, the cubed root of y. So our base number, our big number on our exponent is going to be y. We got to figure out what that power should be. What's the exponent? Well, we can see over here, our index of our root is 3, so this should be y to the 1/3 power. Okay, why don't you take a look at the next one. Pause it quick, try this one out, and then we'll check it here in a second. All right, let's see how you did. This one a little tricky because you can see that it's a negative 1/4. Remember though, we talked about anytime you have negative exponents, we can always move that from numerator to denominator, denominator to numerator. So let's move this one down to the denominator. That makes it 16 to the positive 1/4 power. Okay, well, 1/4 power, what's that the same as? That would be the same as 16, and it would be the 4th root of 16. If you go on your calculator and do the 4th root of 16, you should get 2. So this would be the same as 1/2. Also on this one, you could just take the original problem and just put it right in your calculator and you should be able to evaluate it. So if you do 16 to the negative 1/4 power, and again, anytime you're doing a fractional power, make sure you put it in parentheses. 16 to the negative 1/4 power should give us 1/2. Yep, 0.5 or 1/2. So if it's just numbers, you can just evaluate it right with your calculator. All right, let's talk about some other things now. Remember before we looked at 8 to the 1/3 power? We said that's the same as the cubed root of 8, and we figured out that that equals 2. What about if we have 8 to the 2/3 power? So now not only do we have this number on bottom, but we have a number on top that's no longer 1. So what would that equal? Well, we know this one equals 2, and it's because we have the cubed root of 8. This one, if we kind of just think of this a little bit differently, this would be kind of like 8 to the 1/3, and it'd be like we have 2 of them, because if we take 1/3 times 2, we would get 2/3. Well, we already know that 8 to the 1/3 from up here, that's 2, so this would be the same as 2 squared, which equals 4. So that would equal 4. And again, you can check it with your calculator. 8 to the 2/3 power should equal 4. So just checking that. Yep, 4. So what can we say about this then? Well, on your notes, anytime you have a number to a fractional power, you can think of it as one of two ways. That this is b is going to be under a root. That's our big base number. Remember we talked about the number on the bottom, that's your index of your root. So it's going to be the nth root of b. The number on top though, the m here in this case, that becomes your power or exponent of the base number. So you can think of it as the nth root of b to the m power, or you could switch it around and think of it as the nth root of b all being taken to the m power. When you do the exponent, doesn't really make a difference. Okay, let's look at example. On your sheet, number 5 says evaluate 243 to the 3/5 power. Well, from what we just talked about, 243, that's our bigger base number. Our Radical, our root, would be, remember, bottom number is going to tell you the root. It'd be the fifth root of 243, and then the whole thing taken to the top number, third power. Well, let's go on our calculator. What's the fifth root of 243? So if we do the fifth root of 243, we see that it's 3. So this would be the same as 3 to the third power. And if we do 3 to the third power, 3 times 3 times 3, that equals 27. So 243 to the 3/5 power is 27. And again, with these, you can always just go right to the answer. If you do 243 exponent 3/5 power, it should tell us that it's 27. So there's ways of changing it to radical, or you can just evaluate it with a fractional exponent. All right, let's try another one here. Number 6, they want us to write this one in exponential form. Okay, right now it's in radical form. We want to write it in exponential form. So this one's going to be y. We got to figure out what's that fractional power going to be. Which number goes on bottom in the denominator? Which one goes on top in the numerator? Well, remember from what we said, now the index of the root, whatever root we're taking, that's the bottom number. So 6 would go on bottom. Our power goes on top. So it would be y to the 4/6 power, or another way of thinking about that would be if we simplify y to the 2/3 power. All right, we'll talk some more about this in class when you come.